All right, so this is section 1 of chapter 6. It's tagged in with 4.1 and 4.3, and this is the law of sines and its derivation. So what this is, it's a way that we can relate the sines of the angles to the sides of the triangle, or the measure of the angle to the size of the sides of the triangle, and that way, if we know a certain amount of information, we can find the rest of it. Now, an oblique triangle is a triangle that does not contain a right angle. Figure 6.1 shows that an oblique triangle has either 3 acute angles or 2 acute angles and 1 obtuse angle. Now, you'll remember that acute angles are angles that are less than 90 degrees, and an obtuse angle is an angle that's between 90 and 180 degrees. Notice that the angles are labeled A, B, and C, capital letters, and the sides opposite each angle are labeled with the lowercase a, b, and c, respectively. So across from angle A, you have side A. Across from angle B, you have side B, and across from angle C, you have side C. Now, the relationships among the sides and angles of right triangles defined by the trigonometric functions are not valid for oblique triangles. In other words, you cannot use Pythagorean's theorem on an oblique triangle. So we must observe and develop new relationships in order to work with oblique triangles. Many relationships exist among the sides and angles in oblique triangles. One of the relationships, and the one that we're going to talk about in this section, is called the law of sines. And here's what the law of sines says. It says if angle A, angle B, and angle C are the measures, or those are actually numbers, A, B, and C, are the measures of the angles of a triangle, and A, B, and C are the lengths of the sides opposite these angles, then the ratio of side A, the length of side A to the sine of angle A is going to be equal to the ratio of the length of side B to the sine of angle B, and it's also going to be equal to the ratio of the length of side C to the value of the sine of the angle C. Now, the ratio of the length of any side of the triangle to the sine of the angle opposite that side is the same for all 3 sides of the triangle. That's what this says. This ratio equals that ratio equals that ratio. And what do we notice about each ratio? It's made up of a side divided by the sine of the angle that corresponds to that side. Now, you can also flip the thing over, each one of the ratios. You can't just flip one, you got to flip them all. And you get sine A over A, sine angle B over B, side B, and sine of angle C over side C. That works also. It's just a ratio, so as long as you flip them all over, the ratios still hold true. Now, don't worry about this proving here, proving the law of sines, but what you end up getting is you end up getting ratios of corresponding sides, and those things end up being equal to each other, and that's where the ratio comes from. Now, to solve an oblique triangle, solving an oblique triangle means finding the lengths of its sides and the measurements of its angles. We're talking about all of them. The law of sines can be used to solve a triangle in which one side and 2 angles are known. The 3 known measurements can be abbreviated using SAA, side angle angle, or angle side angle. We've seen these abbreviations before when we were proving triangles congruent. And this could also be angle angle side. It doesn't matter what order, because you can always go counterclockwise or clockwise when you're counting them. So as long as the 2 angles are together and you get them in that order going either clockwise or counterclockwise around the triangle, you get an angle, the very next angle, and the very next side, or the side, the very next angle, and the very next angle. Or then an angle, the side in between it, and the last angle. That's the situations that the law of sines always works for. We're going to talk a little bit about one later where it's a special case, but those are the ones that it's always going to work because you got enough information with two angles that you know what the other angle is. All right, so let's solve the triangle shown in figure 6.3 with A equaling 46 degrees, angle C being 63 degrees, and side C measuring 56 inches. We're going to round the lengths of the sides to the nearest tenth. All right, so we know that we've got A over sine A is equal to B over sine B, which is equal to C over sine C. And all we need to do is plug in the pieces of information we have. We have angle A, it's 46 degrees. We have angle C, it's 63 degrees. And we have side C, which is 56 degrees. Sorry, 56 inches. All right, so we've got the ratios here are the ones that we need. If we've got a ratio here, we have to have a complete ratio, otherwise it doesn't work right. So we have the complete ratio here, and we can find out what side A is, or we can find out what angle B is, either way, and we're going to find out what A is in just a second anyway, but the easiest is, what do we know about the angles 1, 2, and 3 for any triangle? Well, if you remember, all three angles of a triangle are going to add up to give you 180. So if we say 180 degrees minus the sum of 63 degrees plus 46 degrees, this is going to give us the measure of angle B. So B is going to equal 63 plus 46 is 109. If we take that away from 180, we're going to end up with 71. So angle B is 71 degrees. And that means we can put that in right here. And now all we have to do is set up the two ratio, or the two proportions, and solve for the unknowns. So let's take the A. So we're going to end up with just the first one, A over the sine of 46 degrees, equals, and the last one here, 56 over the sine of 63 degrees. And then we can do our cross multiplication, and we're going to find that A times the sine of 63 degrees is going to equal 56 times the sine of 46 degrees. And then of course you'd get your calculator and you would divide both sides by the sine of 63. And that's going to cancel this part out. So A is going to equal this, which turns out to be, and we're rounding it, the lengths of the sides to the nearest tenth. All right, so when we do that, punch that in our calculator, we're going to get 45.2 inches when we round to the nearest tenth. All right, so give myself a little bit more room here. So that's going to be side A, 45.2 inches. And then all I have to do is use this proportion, or this ratio, and this ratio to make my last proportion. So you can go ahead and cross multiply here. So you're going to get B times the sine of 63 degrees is equal to 56 times the sine of 71. And then divide both sides by the sine of 63, 56, sine of 71 degrees, divided by the sine of 63 degrees, and punch that in your calculator to find the approximate answer. And I get 59.4 inches for that one. Now, one thing you need to remember is the longest side is always going to be opposite to the largest angle. So that works out here, and we can check that and see that it does work. All right, you guys try this problem. Try this problem on your own. I'm going to count down here in just a second. I want you to pause the video, work the problem out, and then I'll come back and I'll have the solution up there so you can check your answers. I'm not going to go through step by step and show you this one. I want you guys to try it. So I'm going to pause, or actually it's going to be, the solutions will come up in 10, 3, 2, 1. Okay, so here's the answers, and there's the work. So if you didn't get those answers, you can go back and pause and look at what I did. If you have any questions, make notes of them, and we can talk about them when you come into class. But let's go ahead and move on to the next one. All right, solve triangle ABC if A equals 50, C equals 33.5 degrees, and B equals 76. Round measures to the nearest tenth. Now, guys, on this last one here, notice we had angle, angle, side, or side, angle, angle. So that was the first one that we said would always work. And by the way, it's right there. And with this one, we've got angle, side, angle. So we've got an angle here, the side in between the two angles, and then there's the other angle. Remember, those are the only two that it's going to work on all the time with no special cases. All right, so let's set everything up. We've got A over the sine of 50 equals B 76 over the sine of B, and that equals C over the sine of 33.5 degrees. Now, the reason this works is because, notice we don't have any ratio complete, but we do have 2 out of our 3 angles. So it's easy to find this angle right here by knowing that angle B is going to be 180 minus the sum of the 2 angles we know, minus 50 degrees plus 33.5 degrees. Now, you'll also notice that I'm putting parentheses there. I'm adding these first and then subtracting from 180. So 50 plus 33.5 is going to give me 83.5, and when I subtract that, I'm going to end up getting 106.5. Now, let me go back and double check my work, but I'm pretty sure that's right. (180) minus 83.5. Oh, nope, 96. So I was off by 10. Good thing I checked. So 96.5 degrees. So that's angle B. So we can go ahead and put that in. All right, and then all we've got to do is do our ratios. So here's the one that we're going to use both times because we've got both parts of it, the top and the bottom. So if we multiply by this one over here, cross multiplication, A times sine of 96.5 is going to be equal to 76 times the sine of 50. All right, and then of course we're going to divide both sides by the sine of 96.5. So A equals 76 times the sine of 50 degrees divided by the sine of 96.5 degrees. And we put that in our calculator. 76 times the sine of 50. And I go ahead and find that and then divide by the sine of 96.5. Now, guys, make sure that you are in degrees, not radians. If you're in radians, this isn't working because, well, degrees. So this is one of the few cases we're actually going to use degrees. So you probably ought to make sure you stay in degrees. So we're going to get 58.6 because we're rounding measures to the nearest tenth. So the length of side A is 58.6 and no units are given. So in that case, it's just going to be that. All right, so let's go ahead and do B. Nope, sorry, we got B. We want to do C. So C, let's do our cross multiplication. So C times the sine of 96.5 is equal to 76 times the sine of 33.5 degrees. So of course we'll divide both sides by the sine of 96. So C is equal to 76 sine of 33.5 divided by the sine of 96.5, which is going to give us a value 76 times the sine 33.5 divided by the sine of 96.5, and I get 42.2. Alright, so then when you get done with these problems, you want to list out everything that you found. So here, for me to write my final answer, I would have been finding angle B. So write that down, 96.5 degrees. Side A, which I found to be 58.6 degrees. And side C, which I found to be 42.2 degrees. And that's all you got to do. All right, once again, I want you guys to work this out. I'm going to pause the video in just a second, or actually I'm going to put the solutions up, but I'm going to give you a chance to pause it before the countdown's over and try it on your own and see if you get the right answers. So I'm going to show you the answers in 3, 2, 1. Okay, so here are the answers. Go ahead and check your work, or check your answers, and if you didn't get those answers, round it to the nearest tenth, go back and look at my work and the way I set it up. Guys, I don't take any of these sines and cosines or any of those before I actually do the calculations. I literally type 12 times the sine of 40 degrees into the calculator, find what that decimal is, and then divide by the sine of 117.5 and hit enter. And that's where the 8.7 comes from. If you round intermediate on those intermediate steps, like if you find sine of 40 and round it to 2 decimal places and multiply it by 12, and then take and find the sine of 117.5, round it to 2 decimal places, you're going to be off on these. Don't round it. Leave those decimals in there. Use those decimals. All right, now the next one is what's called the ambiguous case, and it is side-side angle. If we were given two sides at an angle opposite one of those sides, does this determine a unique triangle? Now, when we say unique, that means there is only one of them. So, can we solve this case using the law of sines? Such a case is actually called the ambiguous case because the given information may result in one triangle, two triangles, or no triangle at all. For example, here in figure 6.6, we are given A, B, and angle A. Because A is shorter than the height right here, and the height's just a perpendicular distance there. So since A is shorter than this H, it doesn't actually complete the triangle. So that means that there is no triangle that we can form with the given information. An angle side of size A, a side B on this side right here, and a side A over here of the given length does not give us enough information. Sorry, change that. It gives us plenty of information, but it gives us the information that you cannot form a triangle with this. All right, the number of triangles, if any, that can be found in the side-side angle case depends on h, and the length of the altitude is what h is, and it's found by doing b sine a. So the length of side B times the sine of angle A. That's going to find what that side right there is. Now, where that comes from is our triangle trig. If you remember, if we were talking about the sine of A, it would be the opposite, h, over the hypotenuse, b, in this triangle right here, which is a right triangle, by the way. And all we do is we multiply both sides by b. So that is where we get that h is equal to b sine A. Now, guys, do not get hung up on the A and the B having to be A and B. The relationship between the signs is what you're looking for. So be careful. They may actually throw a C over here, and in that case, this is going to be C that you're going to be comparing this to. All right, so let's look at all the options here. There are two possibilities. Consider a triangle in which A, B, and angle A are given. This information may result in one triangle, in this case, that A is greater than H and A is greater than B. That means that we're going to end up having an obtuse angle right here. And don't forget your height is just a straight line here. So we're saying that A, in this case, is greater than both B and that imaginary H. It's not actually there, but we have to calculate what it should be. It's the minimum distance it's going to form a triangle. All right, so there's one way we can form one triangle. The other way is if we form a right triangle. That's where the length of A is exactly H, or B sine A. So that means we're going to drop straight down along that altitude and intersect the third side, and that's going to form a right triangle. So the case for this one is that A is greater than B. And if A is greater than B, it has to be greater than H, which is B sine A. All right, and this one here, this is where A equals H. So the things I'm writing in red here are the things that help you to identify which one of these you're going to use, or which type of triangle, which one of the cases you're looking at. All right, and then we've got the one where we have no triangle, and that means that A is just going to be less than B sine A, or H. So A is less than H, which is B sine A. And then the two triangle one is this. A is greater than H, but it's less than B. So it's not far enough that that we can't go back in this direction. If we had a B there, let me see if I can draw something here. Let's say we had a line segment right there, and it is longer than B. You can see it there, right? Well, see, the thing is, it has to intersect this side right here. If it intersects this side over here, it's going to have to be out over here, and then we've got this little bitty tiny triangle, which is what? Not that triangle right there. So that means we have to actually go over here somewhere to form the correct triangle if B, or if A is greater than B. So with this case right here with the two triangles, A is less than B, but it's greater than H. So it doesn't go straight down to this side. It's long enough it can swing a little bit, but it's not so long that if you swing it over here, it's going to form a new, different triangle that doesn't have these angles in the middle of it, or inside of it. Remember, A is part of the triangle, so if we were to swing and have a triangle that's formed over here, yes, I'm trying to draw by myself, so I can't draw, then right now we know that this angle A is no longer included in that. So that's why we throw that one out. That's why C or A, if A is greater than B, there's only one triangle. There's not the one that goes back this way. All right, but the two triangles are going to occur when the length of A is greater than this length right here, which is H, but not as much as B, so it can intersect over here and form an obtuse angle here, so forming an obtuse triangle, or it could go over here and form an acute triangle. Possibly acute, it may not be. All right, so that's what you're doing. You're going to find H and then compare it to the other parts to see what situation you have. All right, so in a side-to-side angle situation, it's not necessary to draw an accurate sketch. And the law of sines will determine, if any, the number of triangles, and will give the solution to it. All right, so solve triangle ABC, and I'm just kind of sketching it here. A, B, C. If A is 43, side A is 81, and side B, and let me write these the other way so they look. Let's say that's angle B, and this is angle C. So that would give me 62 right there. All right, so first things first, let's find what H is. Remember, it's B sine A. And in this case, it's 62 times the sine of 43. All right, and I get 42.3. All right, so in this case, what do we know? Well, is A greater than 42.3? Is it equal to it or greater than? If it's greater than or equal to 42, which is, remember, this line right here, that length right there is 42.3. Side A is actually, oh, sorry, that's not right. No, that is right. 81. I shouldn't have had the degrees there, though. Is 81 degrees, which is definitely greater than this. So that means we're forming at least one. And then check to see, is that length greater than this one? It is also. That means we can only form one triangle. So we're looking for one triangle and one triangle only. So we're going to do 81 over the sine of 43 is equal to 62 over the sine of B is equal to little c over the sine of big C. All right, so with this one, hopefully you can see this already. We're going to have to solve this one first because we've got no part of this one. So when we do our cross multiplication, we know we're going to get sine of B is equal to 62 times the sine of 43 and then divide by what I would multiply by sine B, which is 81. Now keep in mind, this is the sine of B, this is not actually B. So when I find that, I've got 62 times the sine of 43 divided by 81, and that gives me 0.5220. I'm going to write 4 decimal places, but I'm keeping all my decimals still in my calculator to use. So then that's what the sine of B is. To find B, remember what we're going to do is we're going to undo the sine by taking the inverse sine of the sine, or we have to take the inverse sine of the other side as well. And that's going to leave me that B is equal to 31 degrees. Because we're rounding to the nearest degree. So 31 degrees is the angle, is angle B. All right, so then all we would do is go back through and find one of the pieces over here. Now if we have 43 and now we have 31, then we can find that third angle, can't we? If we add these two together, we're going to end up getting 43 plus 31 is 74. 74 from 180 is going to give me 106. So that means that angle C is 106. And then if I know that part, 106 right here, I can actually find C. Doing my cross multiplication, and I'm going to use this one right here. No, I'm not. I'm going to use this one over here because that's the one I've got all the information for. So C times the sine of 43 equals 81 times the sine of 106. So C is equal to 81 times the sine of 106 divided by the sine of 43. So in this case right here, I'm only using this ratio and making my proportion. So doing my cross multiplication. All right, and then when I put everything in, I'm looking for the side, not the angle this time, so it's a little easier. So 81 times the sine of 106 divided by the sine of 43, and I get 114.2. And for sides, we were supposed to go to the nearest tenth. All right, so then I can list all my pieces of information. I found C. B I found to be 31 degrees. And then side C, little c, is 114.2. So there's my missing pieces of information. All right, once again, you guys try this one. First of all, determine whether it's going to be one triangle, two triangles, or no triangles, and then solve the triangle situation that you have. If you have two triangles, there are two you have to solve for. So give that a try, and I'll show you the answers here in 3, 2, 1. Okay, so here's the answer. I set it up there and everything in red, and then after this first step right here, I went back and started writing in blue. So I found out what, once we found out what this angle was right here and I wrote it in, I've got two of the three angles, so I could find C right here. So there's my C and B, and then use that last ratio of this one and that one to do the cross multiplication and find out what side C is. So that's where all that stuff comes from. Guys, along the way, if you're taking notes here and you've got a specific question that you can't figure out, make notes of it in your notebook and ask it in class, and we'll get it handled. All right, so this one we already know is not going to have a solution, but I want you to see why it doesn't have a solution. So when we work this one out, we've got B is 71, angle A is 75 degrees, and side A is 51. So the first thing you want to do is you want to find out what H is. H, remember, is this dotted line right here, and it's found by multiplying B times the sine of A. Now, guys, like I said, it's not always going to be A, B, and C specifically in the way that you want it to be. Just remember, you're always going to take the sine of the angle that you're starting from, and a corresponding side is going to be multiplied by it, not the side opposite. You're never, ever, ever going to multiply the side opposite an angle and its trig function. It doesn't work that way. Well, hold on. No, let me not say never. But with this, you're not going to do it. So if we find B sine A, that means we're going to have 71 times the sine of 75 degrees. And that's going to give me 68.6. And that is this length right here. So 68.6 is the length of that purple dotted line right there. Now this is where you can actually kind of see what's going on. So if A is 51, it's only going to go part of the way down. It's not going to make it all the way to this third side. If it doesn't close the figure, it doesn't form the figure. So if it's not long enough, that's where this H value is so important, because that's an absolute minimum value that A must have to form one triangle. If it doesn't have that value, like in this case, so 51 is less than 68.5. In other words, A is less than H, so there is no triangle. And that's all you'd have to say right there, with the work to back it up, though. You have to have the work to back it up, but then that's all you're doing, and you're done there. You don't have to go any further. All right, you guys tried this one. It should not be a triangle as well, but I want you to go through and practice verifying it. I'll show you the answer in 3, 2, 1. All right, here's the solution. That's all you really have to show. You have to find out what H is, and then just compare the H and the A. If the A is not long enough, because remember, this is the smallest side, or the length that that side can have to make a triangle. So if it's not that much, A is not, then there's no triangle. So A is less than H, so we have no triangle. All right, so this one's going to have two solutions. It goes ahead and tells us, but let's go through the analyzation and find out exactly why we know that. So solve triangle ABC. If A equals 40, side A equals 54, and side B equals 62. All right, so we're going to have H is equal to B sine A, which in this case is going to be 62 times the sine of 40. So 62 sine of 40 degrees gives me 39.9. All right, and then remember, that's where you want to check. First things first, is A long enough to make a triangle? So is A equal to this or greater than? Yes, it is. So we know we're going to have one triangle. Now, if it's greater than B, then that means that it goes only in one direction. It can't swing both left to the left and the right of that H to make a triangle. So 39.9 is less than B, but it's greater, but A is greater than that. So we know that H is less than A, but A is less than B. So this means we have two triangles. All right, so let's go ahead and start setting things up. And what you're going to do is you're going to set up your equation, your trig functions, the law of sines, the exact same way we have been. So we've got 54 over the sine of 40 degrees is equal to 62 over the sine of B is equal to little c over the sine of C. Now what you're going to do is you're going to find B the same way we have before. We're going to do the cross multiplication of this part right here, this ratio. So when we do that, we're going to find that sine B is equal to 62 times 40 degrees divided by 54. And when we punch that in our calculator, 62 sine of 40 divided by 54, we're going to get 0.7380. All right, now remember that's the sine value. I want what angle B is though. So I'm going to take the inverse sine of the sine of the -1 of that group of decimals there, and that's going to give me, we're rounding angle measures to the nearest degree, I get 47.56, so that's going to give me 48 degrees. Alright, so if we were to draw this triangle, let's draw a basic idea of the triangle first. I'm going to do the H right here because we don't really know what A is going to do. So this length over here is 62. A is 54, and this length right here is, well, you might as well say 40. So here's the deal. We've got one triangle. Let me draw one triangle with red that's going to go back this way, and that's going to be 54 whatever units. But you can also have one that goes this way, which is also 54 units. Because it's not greater than the B here, doesn't have to swing so far that it would go outside. If it went outside, it's a different triangle. So that means that we have two different triangles here. We have, let me highlight these. We have this triangle right here, and we have this triangle right here. The dotted line is just for reference. It's not part of either one of these triangles. But those are the two triangles that we're trying to solve. Now, here's what I want you to know. If you find that B, and remember this is A, B, C, and we find that angle B is 48 degrees. We just found that one right there. What's this angle right here, though? Well, that's a question you need to know, and we need to know the answer to. But what do we know? Let's talk first about this triangle right here. Well, we know if this is 54 and this is 54, this is an isosceles triangle. And if we have an isosceles triangle, what do we know about the two base angles here? Well, they are congruent as well, so they have the same measure. Well, if this angle has a measure of 48, what does this angle right here have to be? That's my other B, by the way. I'm going to call that B prime. You can call this B sub 1 and this B sub 2. I just always do the prime for the second one. So B prime is going to equal this angle right here. Well, what do we know about these two angles? They're a linear pair, therefore their angle measures would add up to give us 180. So if B is 48, that means that B prime is equal to 180 minus 48, which gives me what? 132. So those are the two angles we're going to have to fuse to solve the rest of this stuff. So we're going to have to actually do this thing twice. The first time I'm going to work it in blue, and we already know what, let's do this one in blue. So we've got all the pieces in the first two, but if we know that we've got 40 here, 48 here, what is C going to be? Well, remember, angle C would be 180 minus the sum of the two angles we know, 40 plus 48. That's going to give us 88. If we subtract 88 from 180, you're going to get 92. So 92 degrees. That's this angle C from the whole thing here, from the big one. So let's go ahead and finish this one out, finding little c using this and this. And we're using the angle here of 92 degrees. So when we cross multiply, we're going to get c times the sine of 40 equals 54 times the sine of 92. So we're going to do 54 times the sine of 92 degrees divided by the sine of 40. And that's going to give me what side C is. So 54 sine of 92 divided by sine of 40. And that gives me 83.957. This is a side, so we're rounding out sides to the nearest tenth. So that would actually round up to 84.0. All right, so have I found all the pieces of information on triangle 1? Well, let's see. Let's go ahead and write them down. So if we do triangle 1, we know that B equals 48 degrees. We know that C, angle C, equals 92 degrees. And we know that little c, side C, equals 84. So we were given 3 pieces of information, and there's only 6 pieces total. So that means we found all of triangle 1. So now let's go back and work triangle 2. All right, let's do this second one in green. So we know that we've got B prime is 132. So that means in place of the 92 here, we're going to have 132. No, wrong place. Right here, 132. But we can still use that to find out what C is. So remember, C prime is going to equal 180 minus the sum of the two angles we know, 40 and 132. So 40 plus 132. That's going to give us 172. 172 from 180. Well, that's real difficult to do. It's only 8 degrees. So we know that C prime is going to be 8 degrees. We know that B prime is 132. So now all we got to do is find little c and we're done. The same way we did here. And the only thing we need to know is that we're interchanging those values. So we know that C is going to equal 54. We're still using the exact same ratio we did just a second ago. So 54 times the sine of C, which is 8 degrees, divided by the sine of 40. And when we find that answer, we got 54 times the sine of 8, and then divided by the sine of 40. That gives me 1169, which rounds to 0.7, so 11.7. So if that's triangle 1, then triangle 2 gives me values of B, that was 132. Let me write this down below it. B prime is 132 degrees, C prime is 8 degrees, and then little c is 11.7. So those are our two triangles that we came up with from this group of this part of information. So it's not any more difficult except for the qualification, finding out whether or not it actually has two triangles or not. That's the only thing that's really added. And other than that, it's just finding the pieces of information that we don't have. All right, so here are the two triangles that we have. Or actually, this is both of the triangles together. Here is one of them. This is the big one. And then here is the little sliver one over here. So we could have A going in this direction or A going in this direction. And there's my angles, 132 degrees or 48 degrees. All right, this one also has two solutions. I want you guys to work it and see what you come up with. And I'll show you the answers in 3, 2, 1. Okay, so here's the answers. Here's the work, the preliminary work to determine, first of all, up here, I did the relationship and found B sine A and compared it to A and found out that A is going to be between H and B, so I've got two triangles. So the first setup I've got right here where I can find sine B is right there. So sine B gives me 0.7647, and that gives me a B value of 50 degrees once it's rounded. Well, if B is 150 and I'm looking at two triangles, that means my other one's going to be the reciprocal, sorry, not the reciprocal, the supplementary angle to that, which is 130. Now, guys, let me tell you real quick why this is the case. Why it doesn't identify just one of these. Well, if you take the sine of 50 degrees and you take the sine of 130 degrees, you're going to get this number for both of those. Sine will not identify whether a number is obtuse or acute when you're doing the inverse sine. When you're doing the inverse sine, it's always going to find the acute angle. Then you have to find the obtuse angle. And we'll talk more about that once we get into circle trig in the next unit. All right, so then we take B here and we put it in and we can go about finding all the parts of C. Well, if we know that A is 35 and we know that B is 50 for that one triangle, we can put those together and find out, subtract from 180 to find out what C is. So C is 180 minus 85, which gives us 95. Anyway, I'm not going to walk through every one of these steps here. You guys know how to do this. If you don't, write down a question you've got about how I did this or something, and we'll talk about it when you're in class. But here are the answers for the first triangle, and here are the answers for the second triangle, B prime, C prime, and little c prime. So check those, make sure you got them correct. Make sure you follow the rounding instructions, and let's move on. Now, the area of an oblique triangle can be found in one simple little memory of your sides. Remember, the area of a triangle is 1/2 base times height. And what we end up finding here is we end up finding the height using a similar thing to what we did with the B sine A. So here we have the area is 1/2 BC times sine A. Guys, the way you remember this is whatever two sides you have, you're using the angle of the letter that you don't have. So if you have side B and you have side C, you're going to use angle A to go along with it. If you have side A and you have side B, you're going to use the angle C. So that's the easiest way to remember this. And this way you don't actually have to go in and work out and find out what the height is, because the height is being found in the equation with the sine A. And of course there's the 1/2. So one of these letters is the base, and the other is being multiplied times sine A to find the height. That's where those equations come from. All right, another way to think about this is that if we draw a triangle out, side B and side C, let's go ahead and do this. So we've got a triangle. Doesn't matter how you label it. I'm going to label up here A just to be difficult. And if we know what side B is, that means we know this one. And if we know what side C is, that means we know this one. Where is A? A is what we call the included angle. It's the angle that's formed by the two sides that we know. So that's another way that you can remember this. And which way, if the triangle is not even labeled, you have two sides and the included angle, then you can solve it that way. All right, so let's do one example here, just to kind of show you. It's easy enough, it's not that big a deal. Find the area of a triangle having two sides of length 24 meters and 10 meters and an included angle of 62 degrees. Round to the nearest square meter. So area is going to equal 1/2 this one times that one. So 24, hold on, let me put the units in here, meters times 10 meters times the sine of the included angle, which is in this case 62 degrees. Now when we multiply these out, what do we know? Meters times meters is going to equal meters cubed. Sorry, meters squared. And then all we have to do is just do our multiplication. So 1/2 of 24 is 12. 12 times 10 is 120. And 120 times the sine of 62 gives me 105.9537111. We're rounded to the nearest square meter, so that means we are rounding to 106 square meters. Now why is it meters squared? Because we have meters times meters, which is square meters. Think about your units the same way you do variables, and it's going, and that cancel out and all kinds of things like that. And it'll help you to keep from making little simple mistakes in setting the problem. If the units don't work out, you've done something wrong. Don't worry about degrees. The sine of the 62 degrees has no units. It's a ratio. It's a side divided by a side. So that's why any trig function value is not going to have any units at all. All right, now we've seen how the trigonometry of right triangles can be used to solve many different kinds of applied problems. The law of sines enables us to work with triangles that are not right triangles. As a result, this law can be used to solve problems involving surveying, engineering, astronomy, navigation, and the environment. Example 7 illustrates the use of the law of sines in detecting potentially devastating fires. So, for instance, two fire lookout stations are 20 miles apart. Here's A, here's B. With station B directly east of station A. Both stations spot a fire on a mountain to the north. The bearing from station A to the fire is north 50 degrees east. That's just 50 degrees east of north. So here is north right here. That means we come 50 degrees towards the east, which gives me an interior angle in our triangle of 40 degrees. That's where that comes from. So this is my bearing angle here. I'm going north, but then I go 50 degrees towards the east, and I need to analyze and find out what my angle inside is going to be. And what do we know about these two angles? They have to be complementary because they add up to give us 90 degrees. All right, and then at the same time, the bearing from station B to the fire is north 36 degrees west. That means here's